Yeah. Hello, everyone. Welcome to our very first lecture on meshing processes. Um, Everyone might be knowing that how important this meshing process is, and as you will come to this platform just to learn how to mesh. And I would like to suggest for 2D meshes at least. It can be done 3D meshes also on this ICEM CFD software that I will be exploring for the first time, and uh, then we'll move to 3D meshing. So first, let's start with 2D meshing, and this ICEM CFD is a very powerful tool for meshing any geometry. And for 2D, it's really, really miraculous software. And for 3D also, it can be done, but I would recommend not to use for 3D because for most complex geometries, it would fail. Not fail exactly, but you might be facing problems because it involves some blocking mechanisms to do meshing. But let's have a grasp because this is very basic tool for the meshing, and if you learn this you'll be able to grasp any software very easily. So first let's start with this tool. This is very powerful tool, and for 2D geometry I always recommend and I always use this one, only this one software. So let's begin with the software. We'll just double click over this ICM CFD icon. Maybe they're on your screen. Otherwise, if it is not available, you just can press Window button on your laptop or the system and start typing uh, ICEM. Then there will be appearing on your screen this ICM CFD. Whatever version you've installed will show up here. Just click over this or here open. Anything you can click and there will be a screen available here. This will open up and pop-ups. So because I have a shortcut here, and well, let me just tell you how to make this icon or make this this icon on your desktop, this shortcut on your desktop, so that you don't need to type it again and search it again and again. So you just first time this type ICEM, and then you go to this open file location you can see here. When you click over this, you'll find this its location where this has been located. Right click over this and come here to this N2 and click over this desktop, create a shortcut. So when you click over this shortcut will be appearing on your screen like that. I've done the same and I've pushed it right here. So I'll double click. Let's not waste our time and start this um, process. And we'll not be exploring too much today. We'll be exploring every day 15 to 20 minutes learning this. We'll be gradually going through deep and deep, learning things. How do we encounter different problems and how do we solve them? So the very first thing we'll be doing is simply the a rectangle meshing of rectangular geometry, rectangle domain. So this tool will first, uh, want you to learn the basics, and you'll always start with the basics. That is the any of the geometry you want to make will start with a point. Then joining those points will create curves, and after curves, when you join curves, you make surfaces. So surfaces are required for 3D geometries. For 2D, it's not very important. But let's see the very first, uh, the very first session, very basic meshing process. How do we do it? So very first, we'll start with a create point. Here's under geometry tab, this create point When you click over it, this will this small window pops up here, and you will have four five options, like these five options. First option will be starting from not exactly, will not be starting with first. You can advanced users can use this for random geometries, because you, whenever you have very big idea or random geometry you want to make, this will be beneficial. But I have this coordinates option. Explicit coordinates option will be beneficial for you for the time being. Say let's click over this and try to look what options do we have here. So we'll be exploring a 2D geometry for the first time. Let's say we have just maybe you can see here. Let me draw a rough sketch of this triangle. Say this is our geometry. Suppose this is our geometry, and let's say this this is, say, 1 meter, and let's say this is not 0.5, it is, let's say, 0.25 meters. So this is how our domain will look like. Okay, 1 meter. Maybe I generally prefer to use dimensions like in but it won't affect very much. So I'm assuming this to be 1000 say this 1000 and I would say this to be 250 Okay, so for the timing, let's come back to this software ICEM, and we have that this in the x direction, this will be 1000 and this will be 250. So how do we decide the point? So let's say this is 0, 0. So what will be the coordinates of this point? This point would be x direction 0, and y direction will be 250. The same way here, this will be x direction will be 1000 and y, 0. This is the point coordinates, and here it will be 1000, 250. So these are the coordinate points here. First, second, third, and this is the fourth one. So let's begin. We'll just enter here. First is 0, 0. In z direction, it will always be 0, because we are gonna we're gonna make a 2D geometry that will not extrude in z direction, so z will always be 0. So first coordinate will apply 0, 0. So it appears like on the screen you can see. The second one will be second one is 1000, 0. This one. This one. This 1000, 0. So let's put 1000 here and say apply. So 1000, 0 has been put on the screen, but you can't see right now. Let's here you can see a small this cross symbol here. This is just to fit to the window. If you click over this, you can see these 2 points being they're fitted over the screen. If you if you rotate your wheel of the mouse, you can zoom in, zoom out to your desired um, position. And if you want to pan this geometry anywhere in the domain, you can just uh, keep the middle button, or the that mouse wheel to be pressed. Keep it pressed and move it anywhere, so you can move it anywhere in the screen. Now the the next process is to put the other coordinates, that is 1000, 250. So we have 1000 already there, and 250 let's put here and say apply. Here you can see the third one. And now which one is the next one? This is a 0,250. So we'll say 0,250 and say apply. Now if you zoom in, zoom out, move it anywhere by pressing middle button, you can move it anywhere. You can pan the geometry. And zoom in, zoom out function will work when you rotate your wheel. Now we want to make it as a domain looking like this one. So we will need curves. So under this geometry tab, there's the other button you'll find is it's a create or modify curves. Let's click over this. So these are the details. There are a lot of options. We'll first begin with the first one. This is from points. So if you click this one, it will show up here the message select locations with the left button, and middle button equal to done, and right equal to cancel. So if you press middle button after clicking the 2 points or 3 points, whatever you want to join, after clicking those with the left button, you need to press middle button. That will be done. So let's see. I click over this and I click over this one, so I created a line. But if you are thinking that I will click over this and I'll join this, there's unfortunately a sad news that it won't work. It won't generate a rectangle. The problem will be that it will fit a curve passing through these. It will predict a curve passing through these 3 points. Let me give you an example. Just click over this. You can see how does it look like. But that was not our the desired curve. So what do we need to do? To cancel this operation, I need to right click, because it is said here that right click is to cancel. I've cancelled. So I'll come back to the previous task. Now, because I've done with this curve, so middle button is to be pressed. Now I'm free out of the command. Now I can join over the next 2 locations. Let's click over this and this, then middle button the same way, this to this, middle button, this to this, middle button, or middle button means the wheel of the mouse. Click. Now there's nothing left. So my geometry is closed geometry now, and I can just finish this by clicking middle button, or just I can come out of the command by saying dismiss. But I generally prefer to simply click middle button. Now I come out of the command. You can see here there is a geometry of 1000 by 250. It's a rectangle. Now the next process was to create surface, but as I said, that this surface is not really required in 2D cases. So I just skipped this. We'll be using it in 3D meshing when we'll see 3D meshes, how that will work. But for the time being, I'll just skip this and I'll go to the this mesh tab. But you can see here it is a mesh tab. Should we go to the tab? Let's see global mesh. pot mesh, surface mesh, and other meshing options are there, that compute mesh and all. Whatever, but I generally don't like this because this produces unstructured mesh and consumes a lot of RAM. This is an automated meshing, and I won't suggest you. It's good meshing, but not really required for the structural meshes. Structural mesh means, what do I mean by structural mesh? Is that structural mesh is kind of a, it follows a particular pattern. Every cell is connected to the next cell. No cell has been, no cell can be, splitted. Let me show you how that. What do I mean by this? This structural mesh. As you can see here, structural mesh means just like I say here. This, say this is the mesh I'm generating. I'm gonna try. Say this is our mesh. Maybe this is our trial mesh. Random meshing. I'm just doing it just to show what do I mean by structural. So let's say I'm gonna put this mesh right here like this, and say till now every cell is connected to every face is connected to the next cell's face, exactly overlapping. But say if I do meshing like this, so here you can see that it has been meshed, but the thing is, this cell is splitted. This face is being shared with these two faces. This cell, you can see this cell is this cell and this cell. These right faces are being shared with this cell's face, this one face. So this is called unstructured mesh. So now what we were expecting this to be a geometry domain. Now we want to mesh it, and as I told you that we won't be exploring these strings under this mesh tab, although it looks like to be the exact thing what we are looking for, because we want to mesh the domain, but we won't be looking into it because this is an automated process and it will be consuming a lot of RAM just to mesh this small and very simple geometry. And we want to make a structural very much controlled, that is under our control, not an automated meshing. We want to control the mesh, how it should look to be. Okay, so we want to construct a structured mesh. So this domain is now an unstructured mesh, because it is sharing, one cell is sharing with the two faces, one face is sharing with the two faces of these two different cells. So now how to make it structured? So now it may be, it may look like a structured mesh now, and not look like it is a structured mesh, because every cell is every face is being shared the single other cell's face. Now a partial sharing is there. This is called the structured meshing. Now of course we want to know how many number of cells would be there in a particular the direction. Let's say what I want to make you know is that wait a minute, one moment, I just want to show what I'm talking about. Yeah, so let it be, see, this is the x direction, and of course this will be the y direction. In y direction, let's say I want to have some particular number of cells to be. Say I want to have just 25 cells in this direction. How would they? You could call it the. This is one cell. This is two. This is third cell, and this is the fourth cell. Such cells. You can see here that for the cells, for a particular number of cells, let's say this is n cells, so number of nodes, how many number of nodes would be there? Of course, this would be n plus 1. It can be verified looking here. This is first node, this is the second node, this is third, this is fourth node, this was third and fourth, and of course this is the fifth node. So you need to add 1, and it's very common sense. I don't think that it will require very much brainstorming. So it's a very simple concept. Number of nodes will be this number of nodes equals number of cells plus 1. Simple, very simple. So this is what I wanted to make you know. So as I was telling you, I want to have 25 cells in this direction, and say 100 cells in this direction. Okay, this would be much easier to look at. Uniformity will appear there. It's your choice, but I'm just taking an example. I'm just taking an example how many number of cells I want. So total of how much cells will appear in this domain? It should appear 25 by 100. That means 2500 cells will be there. So let's start. Let's begin our meshing process. So because I recommend now to go under this to get structural mesh, we'll be going under this blocking tab. Blocking. What is blocking? Blocking will be exploring later on. Exhaustively we'll be going deeper into it. But for the time being, it's blocking is a kind of a rectangle block. However, in our case, the geometry is also a rectangle, but it's kind of a mapping process. Mapping means just like let me tell you here. We have a circle, and the block will look like to be kind of. I didn't make it very good block, but this should touch. Let me make it the other way. Of course, this way I can make it. Full touch. Maybe I can just simply not like that. Sorry, it's kind of okay. The other way I'll be trying. Say we have this circle, and simply it will be a kind of a mapping through some rectangle domain. It will touch this block, will be touching this geometry, and it will approximate this geometry to be a block, because we want structured mesh, so every cell will be kind of a rectangle or a square, whatever you want to have it to be. So the geometry, full geometry, is also to be mapped in such a way that this kind of cells can be generated. So this is very first process to for any geometry to be blocked. So a block can be generated, and that block will be exactly mapped. This area, this whole area, circle area, will be mapped with this block. And this block, what do? We'll just, you know, we will map this line, this line, this line, this line with this curve, and this is called association of curves with the with the edges. And in this blocking scenario, these are called these what the block we've created, all the curves generated from the edge, from the blocking from the block, every curve will be called edge. It will be called an edge. So these are all edges. This, and this. These are all edges. And for original geometry, we will be calling it to be curve. So we can say simply, this is the geometry, and this is block, and we'll be having association process, and this is a very important process. So we'll be having the geometry, and this is a block. We'll be having curves. Okay, let's start from the basic. This is the point under the geometry that we have created, and under block we'll call them to be for this geometry, the points will be called the points. But in this case, because these are to be the intersection points of the edges, these intersection points, let me show you the hint. These intersection points will be called simply the vertex. So for vertex, or for plural, it will be called vertices, that everyone should know. And then it appears the curve. Then here under block, this will be approximated as not approximated, but it will be called the curves generated from this block. These curves will be called, this overall that we've generated, it will be called block. And for the block, of course, there will have to be a similar kind of interpretation, and that will be called an edge, as we have already told. This is an edge. Now, this is the similarity. This you'll have to grab in mind. And now let's start the blocking process. It's very simple. The blocking process is very simple. You just need to click over this, the very first create block tab, and you can say you can rename anything, kind of fluid, or maybe you just can leave it as solid, whatever. Maybe you can just rename it fluid. I'm just renaming. You can leave it blank like that, leave it as it is. And maybe you can select from 2D surface blocking or a 2D planar, it's good to select from 2D planar, but I would simply go through this at it automatically. The very first option, 3D bounding box. It is not a 3D bounding box, but it automatically detects what kind of geometry you have made. So this is always best to keep that. And simply, if you don't select this one, say you're selecting this 2D planar, then you'll have no option to select anything. You just need to apply. It automatically will capture this block. But I always do what I do is that I keep it default, and I select from this select geometry. It is asking for the geometry to be, for the selection to be made. Select entities with the left button. So it's kind of clicking the left button, keep it pressed, and move your cursor like this. Move the cursor on the screen and capture everything that you have made. Everything. It's this block should capture everything. Okay. Now this is the time to leave this. Okay, I left it, and then it is saying that middle button is to be done. Is for the done. Means if you've selected everything, just press middle button, or not the middle button. The exact interpretation for this is a wheel, mouse wheel. You can just press it. Now it is blocked. Now if it appears again, you just can click it again, and you're out of the command. Now you can see some colorful lines have appeared in our domain. You can see some blocking under this tree. Blocking option has also been enabled. You can expand them. You can try geometry. Is having some points, is having curves, and under blocking it is having some edges and vertices also. If you can see the geometry, there is no vertex available here. Let me show you. If I click over vertices, you can see that this kind of these small s, you can see them. So that is the symbol for vertex. Now if I can just make it as appear. And yeah, one more thing I just wanted to let you know that in this ICEM, if you name anything that can't be named as small letters, and this is what it gives an error, kind of error. This is not an error. This is just a warning that the part name Fluid is now valid and changed to Fluid. This is capital letters only, nothing else. So there's no need to worry about this. Simply go ahead. Now you can see. Okay. Now I want to show you how this block has generated the block. What kind of block? It is just exactly acquiring that the geometry what we have made, because it is just overlapping because of the reason that we have already made a rectangle, so it will overlap. It would have been the next lectures will be going through some curved surfaces. Upcoming sections, upcoming lectures, we'll be going through some curved surfaces, curved geometries, and we'll explore. We'll see that this block is a different thing and geometry is a different thing. But you can verify here also. You just disable them, curves, or maybe you can see now. Now you can see that this is a block, and you can move it, and you can see that this is an edge. This is edge. This is edge, and the intersection point of these two is a vertex. Now, if you disable this vertex, these S symbols will disappear. Okay, I'm gonna make them appear. And edges, now you can verify. If you click over this edge, now they're gone. They've gone away. You can verify. And these curves are different things. Let me enable them. So now you can see these are the curves, and these are the edges. Now, okay, let me just enable points also. Let me get back to the original thing. And it's been a big introduction to this thing. Now the process, the next one is to associate, that I already explained. This association is very important thing. Okay, this association is a very, very important thing. Should not forget that. People forget that, and they don't get the desired mesh. So what we are gonna do is we're gonna associate. So association of these two will happen. First, point to the vertex and curves to the edges. So let's associate. Go to the associate. You can see here the fifth one here, this symbol with the finger. That is the symbol of association. If you click over this, you get some options associating. The very first option is associate vertex. Vertex means vertex, of course, that will be associated to some point. Now I'm gonna click over this, and this is telling me select hex or vertex with left button, right click to. If you click right, that will be cancelled. So if you select the vertex, again an option appears over this, pops up over the screen, and this says select one point with the left button and middle button with the done. Okay, I'm going to click over this. I clicked. Now it automatically created that. It associated. You can see here in this console window, done, vertex to point association. Now I can directly go to next vertex to edge, vertex to the point association, because it is again asking for the next hex vertex with the left button. I will say this. I'll click with the left button, and then again it is asking for the point. So I clicked. The same process will be repeated. Left click, left click, left click, left click. It automatically detects the points and the vertices. Now I'm done with all the points and all the vertices. Association is complete. Now I'm gonna press middle button or the wheel. Now I'm out of the command. So what is left? Now curves to edge associations is left. Now you can see that associate, the second option here, associate edge to the curve. So of course we'll be clicking on this. Now it is asking hexa edge. So I'll click over this. Now you can see that some color changes appear. And it is saying that after you select hexa edge with the left button, you click middle button. You press middle button for the done. Now pressed. Now it is giving me the option to select curve. That means the curve, of course. Of course, I'll be associating this curve to the edge I have already selected. So I'm gonna select with the left button, and of course I'll say middle button. Now what was the process? Select, press middle button, and select, press middle button. So this edge was associated to this curve, and you can't see those because those are overlapping. But next sections, of course, you'll be going through some curve geometries, and we'll see how these are different, how these can be seen on the fly. So select middle button, select middle button. The same process with this, select middle button, select middle button. Now this thing is over. We've associated all the curves to all the to the desired edges. Now I'm done. So I can go back. I can come out of the command by pressing simply the middle button. I'm out of the command. So here till here, this was the complicated process. For complicated geometries, it will be somewhat complicated, but as you gradually practice, it will not be complicated, because Actually, this is not very complex process. This is very easy process. It depends on your sequence. How do you remember this? So what was the sequence? Till here, the sequence was to build some curves using some points. So the very first process was to go through the points. Here you can see under Geometry tab, points, and then create curves by joining them. And then what did we do? We just, when our geometry was okay, we went to this blocking tab and we pressed the very first create block, and we just selected the geometry by pressing over there. Gives me the option to select. So selected and simply pressed apply, and got generated. This block got generated automatically by acquiring by some the tangential lines generated the final block. And then after blocking, the process is to associate. An association of what? Association of the points to the vertices and of the curves to edges. Simple. This is what we have done till now. And after that, it begins the meshing process, real meshing process. Now it will become. And why did we do this blocking? Because for the structural meshing, the block is meshed in real, and because block is mapped with the geometry we have made, that means the geometry will be having that mesh. Exact mesh will be replicated over that geometry, and finally we'll be having the desired mesh because we have mapped that geometry with the block. So in real we mesh the block, but because block is mapped, associated to that geometry, that's why we'll be having the mesh exactly of the shape, exactly acquiring, exactly mapping that geometry that we have made, that we want to be meshed up. So this is the process. So now you should know by this time. You should know the importance of association. So you should never forget the association. This is the process you should always remember. After making geometry, you make a block, and then after blocking, you associate all the points to the desired vertices and all the curves to the desired edges. That is the phenomenon. That is the real process. Now the meshing process is very simple. You just go to this blocking tab only. There were some. We'll be exploring these also, but association from this. And now because association has been done, so we'll be going through this, going to this pre-mesh parameters. So simply parameters are to be entered. Now pre-mesh parameter. Click over this pre-mesh, and now there are some options, but because this is update sizes, because I don't have any sizes, ready-made size previously. This is for the mesh you have already created. So, and the second one is the scale sizes. So I will be exploring these also, and edge parameters. Of course, this is the desired one. What we want to a particular edge, because this is an edge, and what parameters means how many numbers of division we want to give it to. So let's click over this, the third. So this is what we really wanted. Okay, there are a lot of options, and you can't scroll them. If you want to scroll, you'll have to do like this, or you may just expand like this. I generally prefer to go like this, but sometimes I prefer to go this way also. Okay, it's your choice, but because we've clicked here, so it is asking for the edge to set the parameters. So simply we'll click over this edge, and now say I'm gonna as I've selected, and it's giving me an arrow option here that has a specific meaning, but for the timing, I'm not going to explain in this tutorial because this will be too lengthy to explain. This arrow is of very much importance. We'll be exploring this, but for the timing, let's just simply say, number of nodes it is asking. This these edge. This is an identity of this edge. The identity, the number, how it detects. So 11, 13, 1. So we want to explore this. This is nothing, just an identity. This you don't need to remember it. Oh, this comes automatically, and this is the length it tells about. So this is the node. How many number of nodes? So for the timing, 2 nodes are default because this is one node and this is the second node. There is no division. Single cell is there. So of course, single cell is there. Cell plus 1. That means 1 plus 1 equal to 2 nodes. Now we want to, as we will explore that, we want some 25 cells. 1, 2, 3, 4, 5, 6, 7, and so on. 25 cells we wanted. Means 25 divisions. That means we will be requiring 25 plus 1. That means 26 nodes. So let's just put it 26 here. Now you can see some divisions appear here. These are 26 divisions. This will be 26 cells. But the thing is, we want 26 here also, at the parallel edge. Here also, we want 26. So the best way is to avoid some errors in future. We always select. This is the best idea to select. Come down here and copy parameters. If you click over this, you can see that this has been enabled to all parallel edges, to visible edges, to selected edges. Of course, I always prefer to use to all parallel edges. This is the default. I always use this. This is the desired one, actually. So as you click over this, you can see that here 26 divisions are there and 26 divisions are there. Actually, these are not divisions, these are number of nodes. So I have selected the number of nodes to be 26. So these are 26 nodes, the dots. I'll show you here. Here you can see that these are the divisions. So you can see that these are 26 nodes. The same way you can click over here, select edges. You don't need to click apply. Even if you click apply, nothing will happen. Simply it will be applied. It is actually automatically applied. You don't need to say apply here in this step. Maybe you can click apply. It's okay if you go for it. And now here you can see that select edge. So if I click here and click over this, you can see that automatically it detects the second parallel edge. Why? Because we already have clicked over here, copy parameters, 2 parallel edges. Now I just need to put some number because now we have changed the edge. Now you can see this identity also has changed, and the length it is showing the length to be 1000. And now number of nodes. How many number of nodes we decided? It was 100 cells, so 100 plus 1 number of nodes. Because here that number of nodes will be number of cells plus 1, and as we were decided to have 100 cells, that means 100 plus 1 equal to 101. So 101, I'll put the 101 nodes. Now it is simply we have done. You can say apply, and this is done. But for the timing, I don't know how the mesh looks like. I have meshed this in real, but this meshing process is not over. I want to see. This is not final. I can change now. In this step, I can change the parameters. If I say one of 1000 nodes, so it will become 1000 nodes here. But I want 101, so I can change in this step. I can change but I want to see how it looks like. So here you go under blocking tab. If you have minimized, you can expand this, and you can say, you can see here there's a pre-mesh. If you click over this, if you hover over this, it will display pre-mesh view. So you can preview the mesh. So if you enable this, it will show you that mesh is currently out of date because you haven't shown it here. It is not because you have made some changes. So it is this warning always appears over the screen when you make some changes. This will show you that is out of date. So you want to recompute? Of course, I want to recompute. Say yes. So this is the mesh. Now you can see this is 100 by 25. You can count them even if you are not satisfied. I can go through counting. This is cell 1, cell 2, cell 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25 finally. So these are 25 cells. The same way these will be 100 cells. Of course I'm gonna not count them. It will be a headache to me. This is just to verify, this was just to verify. And you can see, because we have selected kind of this 250 by 10 equal to 25. So number of cells we have selected 1/10 of the length. Here also 1/10. That means 1000 by 10 equal to 100 cells. So it should give a uniform. That means square cells. So here you can see every cell is a square. Its length and height are the same. So this looks fine. It's a good mesh, and for the timing, this was the this is the mesh we will be exploring. And final mesh. How should we export in a .msh the file format, because this will be the acceptable format everywhere in every software, this .msh. So the mesh is over. This is a preview. Final mesh file you'll be getting from this output mesh. So let's click over here, and the first option is to select the solver. If you click over this, it will give you the option ANSYS Fluent, CFD, and AC Flux, and a lot of options are there. CFD++, and CFX4, and all. A lot of solvers are there. You can export SAR CCM+. I have used it, and I'm really very fond of this. This is very good software. If you compare with the ANSYS Fluent, of course I prefer this, but a lot of people don't prefer this. This is an industrial software, but let's just forget about this for the time being. But our aim was to select the solver. So of course we'll be using ANSYS. So ANSYS Fluent, we're gonna use Fluent for our solver to be. Let's click over this. It was by default there. There was no need to click over it, but I just wanted to show you how it looks like. So simply say apply. Now solver ANSYS Fluent close in structured mesh. Now what is this? Then why did we create structured? Structured, unstructured means kind of a free node, and this is kind of for the timing it is not possible me to explain you, because it won't be understandable for the timing, because it will be another headache for you. Unstructured means simply you can assume that each of the mesh is free of other kind of how to make you understand about this. Kind of each cell is independent of the other cell. That is what does it mean by. But because it supports unstructured, that means we'll have to convert this to an unstructured. So before going to this output mesh, it is necessary for you to go to pre-mesh, right click, and convert to unstructured mesh and say click over this. Now current code in the system is global. And this will give you some warning converting to a unstructured mesh. Done. So of course it is done, and now you can see that those yellow colored lines are gone and disappear. Now it looks like a real mesh. And now I'll select the solver, go to output, select solver, and since Fluent is there, apply, say apply. Now of course it will show again the same warning, but it's just not a warning, it just says a message if you forgot to select, if you forgot to convert this to unstructured. It is just the warning, so that you may have a look. Okay, let's finally go to export the mesh. So here I can see this here, write input, the last option. I'm going to click over there. It is asking for me to save. So, okay, let's just select some folder. I'll say somewhere. I can click over there, space claim, and I can, or maybe it's good to select for me to go to ICE, and I've created some. Maybe I can click over here. ICEM is there, yeah. I can click over there, and I can create a folder. It's good always. It's always good to create a separate folder for separate projects. I'll right click over in this free white screen, and I'll create a folder, say box or a rectangle mesh folder. It is a folder name, it is not a project name. Open, and now I'm gonna rename the project. Let's say rectangle. Sorry, this is rectangle, and save it. Now again it is appearing. I'm gonna because that unstructured file is to be selected. Now I'm gonna go there in the same folder. I see, and then what was this was the rectangle mesh. Now I can rename the project. Maybe I can just rename the same way, rectangle. I can say rectangle. Yeah, it's okay. Rectangle is okay, or whatever name you want. And .prj means the project. Save. Now it's gonna ask you that unstructured file that you've created, that unstructured mesh, and of course you've selected this one and say open. Now it will give you the options to select the options. Of course it's a 2D mesh. I'll click 2D, and I'll under this maybe vocal file you don't need to change. This final output file you can change. You can rename this somewhere, rectangle _ mesh. I've renamed it rectangle.mesh, and I'll say done. Okay, sometimes it's it's failed, so you need to again go to this this option, output file. So let's go and check whether that has generated. It's a kind of a bug under ICM, but no need to worry, because you're at the final stage and you can just have an output in a single click. You can see here what was our line. It's a rectangle, and you can check the .msh file have been generated. So of course now we are successful, and no need to go again and again, go through output file generation. Now I can close this. I can cross this, save project. Of course I have saved it, so no need to save. Maybe you can say yes, but that was not necessarily required. We'll go out. Now the mesh is generated. Now of course you want to see how it looks like in Fluent, so I can it will be kind of extended lecture, but now the very first lecture was necessary to be this much of length. Let's verify this mesh. I'm gonna click Fluent, or maybe if you don't have any shortcut here, you just press window button and search Fluent and say enter. Now this Fluent is asking me to have a 2D or a 3D or whatever solid processes. I always select display mesh. After reading, this is really highly required. If you don't select it, it won't show you the mesh how it looks like. And double precision, this is a preferred one. Double precision is good, always good, because accuracy goes higher. Now I'm gonna say start. It will open up, and I'm gonna show you how it looks like in Fluent, the solver, which finally you're gonna use. So this is now open, and I can just say file, read, and mesh. I'm gonna read the mesh. Let's say, where was the mesh? Go under this. Where is that ICEM? Yeah, this is the folder, and rectangle data message. This is the file. It is showing that file. By default, you can say OK. Now it is importing that the file. So now you can see that this is the mesh file. You can see here. So any valuable suggestions can be dropped in the comment section, and yeah, of course, if you want to make others also learn, you can recommend the channel to other students also. And if you like, you can comment. Maybe you liked it, you can say something, and whatever you want to make, you want to give some suggestions, of course, that are welcomed. Thank you for watching this video, and keep learning. I'll be posting good videos, another advanced videos in this. Thank you. Thanks again. Bye bye.